Welcome to another edition of Straight Fire Math. In episode number 8, we're going to take a look at similar triangles again and begin with this question that I found in a survival manual. The question says, or my question about it is, using what you remember about similar triangles, explain why this formula works to figure out the height of a tree. So there is some additional information here at the bottom that you may have read already, or you could pause the video to read this as well. It gives you further instructions about what you'd have to do to use this formula. Basically, it's saying that you'd have to take some measurements. So to understand the formula and why it works, let's begin by practicing using some information that we could find in real life. So according to this, to figure out how tall the tree is, we'll need to know the shadow of the tree. And let's just make up a number here. Suppose that this is a 12-foot shadow. And we'd also need to know the height of the man and also the length of the man's shadow. So that, let's say this person's 6 feet tall and their shadow is only 3 feet tall or 3 feet long. We can use these ingredients in that formula to figure out the height of the tree. So AB is 12, H is 6 feet, and CD is 3. And that will help us figure out how tall the tree is. So 12 times 6 is 72. Divided by 3 is 24. So the tree would be 24 feet tall. Alright, according to the measurements I made up, it seems like it makes sense that 24 would be right. But why does the formula actually work? So you've probably seen some work with similar triangles already, in my class especially. So thinking about how this actually does work is thinking about the proportions involved. So these two triangles are similar to each other. They have the same shape. They both have a right angle, and they both have the same angle here, at least, as the sun is shining down on the trees. It's making these angles here identical to each other. And since that's true, we know that the two triangles are similar to each other because of angle-angle. And because of that, we can use a semi-famous idea called corresponding parts of similar triangles are in proportion. In other words, if you have similar triangles, you're allowed to make proportions out of them to figure out missing pieces. So if we play a matching game with these triangles here, 24, which is the height of the tree, matches up with the height of the person. And if we continue that matching game, the shadow of the tree is AB, and the shadow of the person is CD. So why does the formula work? Well, all they must have done to get their formula is they must have just cross-multiplied, or just multiplied only one of the two cross products. So as it turns out, they just multiplied H times AB. And you can do that. And you can leave the CD there, and that's how they came up with their formula. Alright, on to some more questions on the back. Well, these are some questions that are similar to the ones or exactly the same as the ones on the state test. So first question or on the back, question number 2. It says that triangle ABCD. The image of this after a dilation with a scale factor of k is the brand new triangle here. So in terms of keeping track of what's happening, the white triangle is the pre-image that existed before. The yellow, which is the image. So it got magnified, it got dilated, it changed its size, but it did not change its shape. So based on the pictures below, name as many correct proportions that could be formed using the segments above. And I gave you a start. So let's see, I said that AB over AD was equal to BC over DE. I just matched up the segments to each other to get that proportion. There's other ones you can make too. So the directions say to make as many as you can. Well, let me do a few. So I could do the bottom. I could do the bottom of the white triangle over the bottom of the big triangle for starters. And since I started with the small triangle and went to the big triangle, I'd have to finish up by going from the small to the big. So I could say AC over its matching side, which is AE. If you haven't done so already, why don't you do another one? Why don't you pause the video and do another one? And now that you've tried one, how did it go? So let's see. Another possibility you could have done is AB over BC. So it's okay to make a match this way, to do AB, the left side, over the bottom, and then repeat it by doing another left side over a bottom. Now these are some examples of the many proportions that you could actually make up, matching up the corresponding sides and putting them in proportion. So all right, so the bottom here has got some exact examples. So for question B, it says suppose that AC is actually 9. And it says CE is 11 and AD is 10. It says determine AB to the nearest tenth. So in my picture I'm looking for AB. I'll put an X there as a reminder for the fact that I'm looking for that distance right there. And now I need to make a proportion up that will have those ingredients in them. So taking a look at what I've got, I could start off with the X over the 10. So the X is the left side of the small triangle, the 10 is the left side of the big triangle. So I went small triangle to big triangle, small triangle to big triangle. I've got to do that again. Small triangle to big triangle. So I did X over 10. I have to finish 9 over all of that, 9 over 20. Then cross multiplying will get me close to the answer. So I get 20x equals 90. Dividing by 20 will get me 4.5. And it looks right in the picture as well. Alright, this is based on the picture above. Explain why BC must be parallel to DE. Well, what do we know about the triangles? It says that there was a dilation. And a dilation makes or forms similar shapes or similar triangles. If the triangles are similar, their sizes are not the same necessarily, but their shape is. So angle E is the same as angle ACB. So these two black angles there are exactly the same. So why would these two segments be parallel to each other? Well, if angle E is equal to angle ACB, the black angles are the same, the alternate interior angles are equal, and that must make the lines parallel to each other. Okay, we got one more page. I'll start you off on the last page. So for question number 3, they're telling me that the triangles are similar to start off with. And I'm looking for which proportion could be used to solve for x. So I'm looking for the correct one. Since the triangles are similar, I can use the fact of corresponding sides of similar triangles are in proportion. Of course, this time I did say it correctly. We're talking about the sides being in proportion. So we're looking for good proportions or good matching that's going on. So let's talk about which one is correct. Let's take a look at each of the choices. The very first choice has x over 24. So the person that did that did the longest side over the shortest side. So the second fraction should be the longest one over the shortest, and it's not. It's backwards. So these two should have been switched. So it's not the right choice. Let's look at choice number 3. They did 32 over x. So they did looks like the medium side over the longest. And then they did the medium side over the longest. So that's showing off some good matching. That is the one that's correct. Of course, if you wanted to really make sure, you could cross multiply that and see if it actually comes out to be an answer that's realistic. So 12 times x is 12 times x. 15 times 32 is 480. And then dividing by 12 tells us that x is equal to 40. If you look at the picture, it does make sense. The 15 was the longest side in the small triangle, so this should be the longest side in the bigger triangle. Alright, and I guess question 4 will be up to you to finish, because I'm not going to do every single one with you, but here's one more question that should get you ready for tomorrow's quiz. Alright, well, just keep up at all this hard work that you're putting in. Every little bit makes a difference.